So let me take a door now. This is the axis of rotation, or it is hinged, no? It can rotate clockwise or anti-clockwise, anything. I'm just showing arrow so that this is the axis of rotation. I think it'll be hinged like this, no? Here, like they said, 3 or 4 places it'll be hinged. Now you do one thing, it's very simple. Let me define the coordinate system. Z-axis, x-axis, and this is y-axis. I'll apply force parallel to, no, it is hinged about y-axis. Things are a little bit different here. It is hinged about y-axis here. I'll apply one force, this is F1. Next, the other force, F2. Another force here, F3. F1 equal to F0 minus F0 J cap. Some value. F2 equal to F0 I cap. F3 equal to, say, some 2F0 J cap. F4 is equal to minus F0, or say like a minus 3F0 K cap. F5 is equal to 2F0 plus K cap. This length of the door. So let this be L by 2. Let this be L by 2. Height of the door, let it be H. The point of application only, let me take that. So these are the some forces which are acting here. So this, if you want, you write X3. Any of symbols you can apply it. Let's go for the forces acting. What about the force F2? What is the axis of rotation? The door rotates about y-axis or hinged about y-axis. It is like this, hinged about. I'm using word hinged. So definitely what happens? It can rotate only about y-axis, no? Let's come for F1. If I apply force F1, then if the door is set free to rotate, then what will happen? It can rotate about z-axis. Am I right? If the door is not hinged here, then due to F1 open, it can rotate about z-axis. But since it is hinged about y-axis, so can this F1, can it set up a torque? Sir, according to formula, L cross F1, L is non-zero. And what is F1? F1 is also non-zero, and angle between L bar and F1 bar, 90 degree. So according to formula, L cross F non-zero. But look at this force. It is acting parallel to y-axis, so it will not set up a torque. Able to make it out, F1. What about F2? It is intersecting axis of rotation. Look at F1. F6 also there. F1 is parallel to y-axis, torque will be 0. F2 is parallel to axis, which will intersect axis of rotation. What about F6? F6 also will intersect axis of rotation, torque will be 0. Clear this. Then what about F3? Parallel to axis of rotation. So here F1, F1 bar and F3 bar are parallel to axis of rotation. So therefore will be 0. Then what about F2 and F6? F2 bar and F6 are intersecting axis of rotation. Will be 0. Let's calculate due to F4 and F5. Torque due to 4 should be equal to Li cap cross, what is F4? F4 is how much? Minus 3 F naught K cap. K cross I will be J. I cross K will be J. So this will be 3L F naught J cap. Torque due to F5. L by 2 I cap cross F5. F5 is how much? 2 F naught. 2 F naught K cap. So this will be L F naught. I cross K will be minus J. Therefore, what is the resultant torque here? The resultant torque is only due to T4 and T5. So that should be equal to how much it is? 2L F naught J cap. How the door will rotate? After some time, where the door, what happened? This edge will be there in X minus Z plane. Am I right? This edge, where it will be there? It will be there in X minus Z plane. Now it is along X axis, this edge. Or this particular edge will be there in on X axis. After some time, will be there in X minus Z plane. So if this is the house, please do understand these are very general things and nothing to do. Now initially what happened, the door is closed here. So when I apply such a torque, the door what happened will get okay, this is 2. And door I'll show by red color. Is it okay now? I just like a pushed into the house it is. So you have in your home many for windows, doors will be there. The door will be there for every room. Cupboards will be there. Just do check. Your teacher has shown. Just analyze once. Once in a life you analyze. Huh? I can say that you will be in a comfortable position. You can manage very easily with numericals. The door is the best way to learn the torque idea. I'll try to 10 minutes is there. No? Let me explain with the door I'm having. I'll throw with the door. Directly I'll show with the door. I don't think so. This will be. Wait, the wire will extend it. Equal wire.
Can you hear me?
Okay, fine. I had to show a video, no? You are able to see the door. So
Can you hear me? Voice?
Yes, sir.
Okay, I'll take the example of it. Are you able to see the position of the door? Now I'm applying a force here. Okay. So what is axis? This is axis. I'm speaking loudly, so try to understand. So this is the axis of rotation. Just wait. This is the hinge, no? This particular thing will be hinge. So the door, if what happens, is going to rotate about that y-axis. So what is the axis of rotation? This is not axis here. The axis of rotation is this one. Now I'll apply force. How I'm applying force? So the first one, I'm applying force in this direction. Why it is not opening or closing it? Why it is not opening or closing it? So I'm trying to see this. Any reason? Because this is the axis of rotation. This is the axis. So how the force is acting? It is in the direction. So shall I say it is intersecting axis of rotation? Why I'm unable to open it or close it? Any reason for that? Because here the door, the force is intersecting axis of rotation. So directly the force will be like this. I'm trying to show this one. So here, not opening, not closing. Any reason? Though I'm applying a force. Any reason for that? Because the force will intersect axis of rotation. This idea. So now you see this one. I'm trying to. I'm striking with a stick. No, why it is still I'm unable to open or close it? Because if the axis, this axis, and the force is acting here. You can see this one. The force is acting parallel to axis of rotation. I think can I'm unable to open or close it. No, any reason? Because the force is acting parallel to axis of rotation. Now you can see clearly. One more example, what we discussed. No? I'm able to close it. No? Any reason for that? Because the force what I applied is this is distance r and this is a force. And look at this r bar and there is a bar r cross f. Therefore, the door is getting closed here. If I want to open the door, what I should do? I'm going to. So what is r bar now? This will be r bar, and f bar will be like this. My arm will be f bar. This will be f bar, and this will be r bar. R cross f. Thumb will be upward. You can see. So now what I'm doing, I'm. So how the force? The force will be acting like this, and this is the r bar. R cross f. So how thumb? The taunt will not be here. The taunt will be acting here. The torque will be acting at this particular point. The torque will be acting at the inch along y-axis it is. So now what happens? I'm opening the door. So when I'm opening and closing the door, what is the direction of torque? Try to realize it. So when I'm closing the door here now, the torque will be directed vertically down. When I'm opening the door, so here is what I applied a force. So the force will be like this. R cross F. The torque will be here about the axis, it will be upward here. So like this, you can stick with an example, take door, try to analyze the exact picture like, oh, this is what I'm studying the torque. a force intersect axis of rotation, no torque is set up. If a force acts parallel to axis of rotation, no torque is set up. That's what the basic thing is. I'll come back to next one more case. In classroom, it's very easy. Within 5 minutes, I'll wind up this topic. But here, since we don't have any suitable examples, no, I'm giving so many diagrams because the torque idea is very important. Without torque, no way learning rotation mechanics is as good as like we are wasting time. Let me discuss the last two more cases.
To watch some videos, everything. No, I'll try to give few more diagrams separately. And now, if it is a torque, I'm giving this one. So this everything you do practice with respect to some door, that will be much easy for you. Okay, we'll take the last one more. There are two ways in which already the basic. Once again, I'll go back to the basic thing from where we started.